All right, welcome back. In this video, I'm continuing a discussion of Venn diagrams and set operations with a few practice problems or examples. So I've started by defining the set U. It has the letters A through G, and a set A that just has the vowels A and E, and a set B which has the elements A, B, C, D, and E. So let's start with a Venn diagram to represent these sets. So here's my universe. I'm going to use this for A and this for B. And so the elements A and E are in both A and B. In fact, that's all of A. But B also has the elements B, C, and D. So this is interesting. A is entirely contained in this intersection. All right, so let's see how that works out in some of our with some set operations. All right, so what is the set A's complement? So the elements that are in the universe that are not in A. B would be included, C would be included, D would be included, F and G. So those are the elements that are in the universe, but which are not in A. Now, in my Venn diagram, here's A, and that's everything outside of A in the universe. Oh, I should have said, here's A, B, C, D, E, so F and G are out here. Let's see, what about if I wanted to say A intersect B? What are the elements that are common to both A and B? So that's just the set A and E. In this case, that happens to be A intersect B equals set A. And remember, we only use the sign equal when they have when two sets have exactly the same elements. And so A intersect B has the two elements A and E, and those are the same elements that are in set A. So those two sets are actually equal to one another. What about A union B? So that's when I kind of marry these two sets together. That would have A, B, C, D, and E. And notice that that is equal to set B. All right, what about let's say the complement of the intersection? So all the elements that are not in the intersection. So the intersection is here. It's the A and E. Now what are all the elements that are not in the intersection? Well, that includes B, C, and D, because those are not in the intersection, but it also includes F and G. So they're in the universe, but not in the intersection. And if I wanted to say A union B's complement, that's everything that's not in the union. So the union is this, again, that's like a snowman shape, and so that's just the things that are not in the union, so but still in our universe, so that's F and G. So those are just some, and of course there are other things that we could do here. Remember, we discussed in the previous video that this is going to be the same thing. The complement of this intersection is the union of the complements, and so that's a nice way to convince yourself of this. So we already looked at the complement of A. Let's think about what the complement of B is. The complement of B, so B has A, B, C, D, and E. So this just has F and G in it. So I want the union of the complements. So if I take the complement of A and combine it with the complement of B, so that has a new set B, C, D, F, and G. If it's in either one of these, it's in this union. And notice that those are exactly the same. And if I take, here's the complement of the union. Let's take the intersection of the complements, A complement, B complement. Now, the intersection is things shared by A complement and B complement. So the things that those have in common are F and G. So this is F and G. And notice that's the same thing that we found here. So those are just some interesting facts about set operations. All right, so let's look at a few other examples where we're, I'm taking this from a textbook, and I want to focus on, firstly, on some problems here. Let me just actually tear this off and make sure that we can see this. I'm going to have to adjust this down a little bit, give it a chance to focus. One second. Let's see if I can focus this a little bit better. Yeah, okay. So here we said a math tutor working with a small group of students asks each student when he or she studied for class the previous weekend. Their responses are shown in the Venn diagram. So some studied on Saturday, some studied on Sunday, and then there were a couple of students who studied both days. So let's look at the even numbered questions here. So 110 and 112. So use the Venn diagram to list the elements of each set in roster form. So the set of students who studied Sunday. Now we're going to call that set SU. And who all studied on Sunday? Well, Emily, Hannah, and Ethan all studied on Sunday only. But Mike and Josh also studied on Sunday. They just happened to study Saturday too. So I would also need to include Mike and Josh. All right, this set of students who studied Saturday and Sunday. So that's Saturday and Sunday. So that's an intersection. That's just the two people here in the middle, in the overlap, and that would just be Mike and Josh. Okay, so again, I want to just emphasize that an intersection is equivalent to an and statement, whereas a union is equivalent to an or statement. Okay, and let's see. I'll also do number 114 here. The set of students who studied Sunday, but not Saturday. Sunday, but not Saturday. So Sunday, but not. So Sunday, and not Saturday. So that would be this group of people. Sunday, but not Saturday. Just Emily, Hannah, and Ethan. And so that's Sunday intersect, not Saturday. Okay. Yeah. All right. And then the last one here, the set of students surveyed by the math tutor. So that's your universe. And so that would just be, Ashley, Mike, Josh, Emily, Hannah, and Ethan. That's the universe there. Okay. Let's do the next, look at the next example here, where you have, use the information in the graph to place the indicated job in the correct region of the following Venn diagram. So the bar graph shows the percentage of Americans with gender preferences for various jobs. So they prefer men, they prefer women, or no preference. Elementary school teacher, let's see, using information on the graph. The set of jobs for which more than 20% prefer men. So where's the 20% line? there's the 20% line. And more than 20% prefer men. So the darker line is is the percent who have a preference for men. So that would include police officers. The dark line goes above this. Surgeons, airline pilots, family doctor, and lawyer. So those are in set A. And set B, the set of jobs for which more than 20% prefer women. And that would include, so prefer women is this, the middle bar. So that would include elementary school teachers, but not police officers, bankers, not surgeons, not airline pilots, but also family doctors, and it looks like lawyer is, I want to say it's in both of those. So the red are the professions that prefer women, the blue are prefer men, and then let's see, there's overlap. So family doctor and lawyer, those are circled in blue and in red. So this region, that's the overlap, that includes family doctor and lawyer. And so area this, though, includes only the teacher and banker. And this region would be police officer, surgeon, and pilot. Okay. All right, so then what are we asked to do here? Use the information to place the indicated job in the correct region. Oh, yeah. So elementary school teacher, that's in region 3. So here. Surgeon is in region 1. And family doctor is in region 2. The police officer is in region 1. And banker is in region 3. And lawyer, that's in here in region 2. Did I, let's see, family doctor. Yep, I said in region. All right. So those are a couple of examples of some problems where Venn diagrams can help us understand sets and set operations. All right. See you next time.